Hello class, today what we're going to be doing is truth tables. So first off, the reason why we're doing truth tables is because this old guy called George Boole, they make him look like this, he actually looks like this. He basically made true-false operators to be 1 and 0, which led to De Morgan's law, which is another old guy, but we'll talk about him later. Basically what we're learning today is true or false. True or false, true or false. So basically, this is the actual code in Java that it looks like when you're going to be making it. Realize Fenton and X are variable names, which could be anything. We're assigning the value true or false. Please realize most of this stuff I'm going to breeze by, then I'm going to teach you. So I want to give you an overview of it first, and then we're going to go into specifics. So if we want to set up a truth table with two variables, we go true, true, false, false. And then true, false, true, false. And just remember that all these notes are already posted online for you. If we want to do three variables, notice that this pattern right here is this pattern right here, which is also this pattern right here. And all we're adding on is one option to be true and one option to be false. So it's really easy to make. Now, what I want you to take a look at is we're going to relate this back to binary. So in the back of your head, I want you to assume true is 0, false is 1. This is technically wrong. This is only for this slide you're going to be thinking that. So if true is 0, we're going to start with 0. Then in binary, we're going to count to 1, 0, 0, 1. Then 2, 0, 1, 0. Then 3, 0, 1, 1. Then 4, 1, 0, 0. Then 5, 1, 0, 1. And look at this. It's the same exact pattern. Now the reason we're thinking true to be 0 is because we always want to look at the true, true, true case when we're doing truth tables instead of the false, false, false case. But technically, if you wanted to, you could invert this and go 1, 1, 1, and then count down from 7 all the way down to 0. Then go 1, 1, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, and 0, 0, 0. And you could do truth tables this way if you want to. There's nothing wrong with that. I don't care if you write true or false or 1 or 0. False takes at least 2 strokes. 0 takes 1. 1 takes 1. True takes 2. So 1s and 0s are faster, but that's up to you. Okay, so now what we're going to do is do a basic layout. Again, we're setting up with true, true, false, false. True, false, true, false, which you learn in geometry, so this is actually going to be in your math class before you graduate. So you're not just learning this for this class. If we're looking at not x, we look at x and invert the answer, which true becomes false, true becomes false, false becomes true, false becomes true. If we're looking at not y, which is exclamation mark y, which is also over here, which is also line above y, it's false, true, false, true. Now x or y, we're looking at x, we're looking at y. We ask ourselves, is there a true? Yes. Is there a true? Yes. Is there a true? Yes. Is there a true? False. With x and y, we say, is there a false? No, so it's true. Is there a false? Yes, it's false. Is there a false? Yes, it's false. Is there a false? Yes, it's false. These operators also translate to English. But all we care about is if it's a 1 or a 0. So again, lights on, lights off. Lights on, lights off. Why are we flicking the lights? Because in a computer, you either have it on or off. There's nothing else. So we can either send power to the light bulb or we don't send power to the light bulb. There is no halfway. Even though you guys know what dimmers are, that's too complex. So let's take a look at these gates. If we were to take a look at the AND gate, it's just like taking a look at multiplication. What's 1 times 1? This is 1 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. Just like true and true is true, true and false is false, false and true is false, and false is false. You see how it lines up? So to fill in the truth table, we go true, true, false, false, true, false, true, false. True and true is true, all the rest are false. Oh man, that cough is terrible. It's as if this is going to be on the test verbatim. Easy way to remember this is and is bad, that's why it's red. If either one is false, it's false. Or is good, that's why it's green. Green is good, red is bad. If either one is true, it's true. So you might want to write that down. On Box.com, we have truth tables and De Morgan's and logic circuits. And then click on notes. And then click on and or rule. And there you go. It's already made there for you. But let's move on. So if you want to write it down, just write down and or rule. Next one is the OR gate. Realize the OR gate is just like addition. What's 1 plus 1? 1. Weird. But technically it's 10. We're just not looking at the 0. We're just looking at the MSB. But just assume that it's 1. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. Just like true or true is true, true or false is true, false or true is true, and false or false is still false. So we just fill in a table. Now these also translate to English. So the grass is blue and the sky is green. It's false. Does everyone see that? The other one to do is Mr. Fenson teaches at Forest Park and Mr. Fenson is a teacher. Hey, that's true. The other one is Mr. Fenson is a billionaire and Mr. Fenson is a teacher. That's false because one of the statements is false. I'm not going to tell you which one. But let's look at or. Mr. Fenson is a billionaire or Mr. Fenson is a teacher. That's true. Because the word or means either one. So you will pass this class or you will not pass this class. Well, one of them's true. The not operator. So if I said you'll pass this class and I nodded that, it means you will not pass this class. Just like in English. So if it's 1, what's the opposite of 1? 0. What's the opposite of 0? 1. What's the opposite of true? False. What's the opposite of false? True. So when we fill this table out, we get this, and then it becomes false, true. But for x, usually we go true, true, false, false. So it would be false, false, true, true. It is not this in logical element. It's this little dot at the end. This means one way, so it doesn't allow it to pass. Now we have two options. You can memorize all these rules, which is a pain. Or you can do these things called K-maps, which allows you to simplify things, which we'll get into later. So let's take a look at this. When I teach math, I tell them to circle the variable, take care of the hater. So we circle the variable. The hater is everything else. But then we can circle the variable because the 4 is closest to the x. Now we have 2 haters. And the next circle would be adding the 2. So the first step would be multiplying by 2. Does everyone see that? Because dividing by 2 is everything. So that cancels out. So we're left with 18 equals 4x plus 2. So we circle the variable, simplify this down to one variable. We take care of the hater, which is the positive 2. So we subtract 2 from both sides. We get 16 equals 4x. And then again, we circle the variable, take care of the hater, divide by 4, because the opposite of multiplication is division. So we divide both sides by 4, we get 4 equals x. That's how we do it in math class, right? Well, in computer math class, we do the same thing. We first have to solve for negative x in order to solve for not x or y, in order to solve for the whole statement. So to do this, when we set up the truth table, we need x, y. Then we need not x. Then we need not x or y. And then we need not x or y, in parentheses, ANDed with x. So we do is we solve this, which is easy, it's given. Then we solve this, then we solve this, then we solve this, and we have the answer. But you can't just jump right to this because you have to solve for all cases, so you need to fill out the truth table. So let's do that. Go ahead and try this. So what we're going to do is, so to do this, if you hit the print screen button, which is right here, print screen. Click, just print screen. Then you want to go to Paint, so click Start. Type in PAINT into the keyboard, and it pops up, Paint. Click on Paint. Then you want to go Paste right here. Click on Paste. And it pastes your screen. And now what we can do is, I would click on Red. I would click on Pen. I would also click on Size, Go Big or Go Home. And now you can actually just fill in the table. True, true, false, false. The best thing about this is then you can go File, Save As, and save it in your documents. And name it anything you want. You don't have to save it, but I would recommend it. True, false. True, false. And then we look at not x, which is from x, so I put a little dot above there. So I'm looking at this column, so I go false, false, true, true. Then I look at the next one, which is not x and y, which are these two right here. So you can either circle on top, or I like to put a dot on top. Or you can put your hand to block this completely. So not x or y, I have a true, so it's true. I don't have a true, so it's false. I have a true, so it's true. I have a true, so it's true. We're going to look at these two in brown. So I'm looking at this one and this one. Since it's the last column, in my mind, I'm covering this up with my hand. So true and true is true. False and true, there's a false, there's a false, and there's a false. So my answer is true, false, false, false. So I'm going to go here. There's this thing called an expert column. Why did I put expert column here? Well, where did we see true, false, false, false before? This is simply equivalent to x and y. Because x and y is true, false, false, false. Well, that's weird. Why write this when I can write this? Well, every year I facepalm when I look at freshman code. Because they write all this nonsense to just do this one thing. So there's nothing wrong with doing this. This still gives the correct answer, so it's still correct. But let's think about this for a second. If this one gate right here costs 20 cents, that means this one gate costs 20 cents. Technically, there's a 3 input, so it should cost 30 cents, but we'll just assume it's 20 cents. That means we have 1, 2, 3, 4, 5, 6, 7, 8, 9 gates. So we're going to multiply that by 9. We get $1.80. But this is just 20 cents. So it's $1.60. Who cares, right? Well, let's take a look at the Xbox 360, which I know I'm dating myself, but I actually had to pick an old one so I got this number correctly. I tried iPhone 7. It didn't work because they didn't have good numbers. What that means is if I was part of making the Xbox 360 hardware, they sold 84 million units. If I multiply that by that $1.80, we're looking at $151 million compared to $16 million. Do you think someone would get fired over that? Well, subtract the 2, you get $131 million. I think about 262 people would get fired over that. There's lots of other reasons why you should reduce yours, not just cost. How many things can go wrong here? How many solders is this? 3, 6, 9, 12, 15, all that take processing time on the construction conveyor belt. Compared to 1, 2, 3, 4, 5. Done. First thing you want to do is true, true, false, false. Next thing you want to do is true, false, true, false. Here comes the tricky part. What goes here? We need to break this up into two problems. We have one problem, two problems. So we write this over here, x or y, and y and x. And now we solve for these individually. Y and x, true and true is true. If there's a false, it's false. If there's a false, it's false. If there's a false, it's false. Next one, x or y. If there's a true, it's true. If there's a true, it's true. If there's a true, there is. It's true. If there's a true, there's not. Therefore, it's false. And now we do when we solve this one, we're looking at these two columns right here. And we're doing the OR operator, which means if either one is true, it's true. So go ahead and give that a shot. Bang! You should have gotten true, 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 false. Why so complex? Why? When you could have just done X or Y. Gotten the same exact thing. What a coinkydink. And also, whenever you need more space, you can just make your own little lines here. You can do that. So again, when we're doing this, we want to remember, how do I break this problem up into multiple problems? To do that, it's just like math. You know how to break this up into multiple problems. You multiply by 2, you subtract, then you divide by 4. Well, you're just taking these problems through here and just breaking them up. You can break them up any way you want to, really. It'll work out. It's commutative. I put A. Does that matter? No. A can be X, B can be Y. So you're just filling in the truth table just like you did before. True, true, false, false. True, false, true, false. But now try the rest. Okay, so when we do not B, we're looking at the B column and just inverting. False, true, false, true. Then we look at A or B, which is A or B. If there's a true, it's true. If there's a true, it's true. If there's a true, it's true. If there's a true, there isn't, so it's false. And then A or B is right there, and not B is right there, and we're anding them together. False and true is false. If there's a false, which there isn't, therefore it's true. If there's a false, there is, so it's false. If there's a false, there is, therefore it's false. Now you don't know it, but this is equivalent to A and not B. You'll figure out how to do that later on. But here's the money screen. Go ahead and take a look at this. It's all color coordinated, so you should be able to figure it out. So look at it real quick, then I'll go through it. First step when you're doing this, make a table. That black thing right there. Next one, make a variable for each, a column for each variable. 1, 2. Next one, blue. If you have a third variable, put in a third column. Blah, 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 blah. Then there should be 4 more rows. Because my rows equals 2 to the variable count. There's 3, that's 2 to the third, which is 8. Hence 8 columns. Next one, anytime I need a not variable, which not can be not, both are the same thing, just different syntax. I need my not column. Next, I need to break up this equation into multiple equations, which I did right there. And my not y is already right there, which is already broken up. Then I need to fill in the basic values, which what I consider not also basic, because it's a no-brainer. And then last but not least, solve. Start here, work your way here. Don't read it like a book, though. Start on this column, go down. Then go over. Then start here, go down. So on and so forth. Because you need every column to do the next column. So if you go on Box.com, go to Truth Tables, De Morgans, and Logic Circuits, then go on Notes. And under Notes you have K-map directions, which is right here, which I'm going to rename Truth Tables direction. What's the variables you have? A, B, C. A, B, C. That means you go true, 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 true. False, 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 false. What's the last column? A or B or C. You should be able to figure this out. You should be able to fill these two columns out. Well, all four columns out. Don't worry about this just yet. So you should have gotten true, true, false, false. True, true, false, false. And then true, false, true, false, true, false, true, false, true, false. Now here comes the hard part. How do I break this up? Just take the first two. A or B. A or B. A or B is only going to be false on these last two. All the rest are going to be true. If there's a true, it's true. If there's a true, it's true. I'm looking at these two columns. True, 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 false, and false. Now what we need to do is look at this column right here and this column to get this whole thing. True, there's a 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 true, and both are false. Well, here's another thing real quick. We have A and B and C. We can either make a whole new truth table the same exact size, or we can append the truth table just by going like this. Saying, well, we got two more columns. My last column has A and B and C. What goes here? A and B. Could also be B and C, but I won't get into that. So we take A and B, which are the first two columns. True, true. False, 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 false. If you notice, it's just like the 4-gate one, except every true is 2 and every false is 2 falses. Because there's 8 options. Then we append this with C, which is right here. Let's do a different color. C and A and B. So true and true is true. False and true is false, and these are all false, so these are all false. Because if there's a false, it is false. Take a look at this chart. This is probably the biggest misconception. A and B is not the opposite of A or B. Because what I want you to do is look at the purple, which is her and right her. Opposite means not the same, but these are the same. Opposite means not the same, but these are the same. That means they are not opposite. Comprende? Comprende. Oh, man. A and B is not opposite of A or B. This is literally class CS 210, a quasi freshman to sophomore level class, a semester long course, which means half a year. The truth table part of it is basically the show your work section of it. Every processor, that means your 3 gigahertz quad core processor, is made out of ands, ors, and nots to some degree. It's on the AP. And Java wouldn't work without it, because to make machine language, we need these ands, ors, or nots. And we take Java and convert it to machine language, which is then operates the machines. So without true and false, we wouldn't have a computer. Now that you're done, what I want you to do is work on 121. So let's take a look at 121 in a different movie. Have a good one. I will see you later.